Okay, welcome back. Now in this video, we've already defined what left-hand, right-hand limits are in a previous video. Now in this video, what I'd like to do is have you look at this example 1.11, and I want you to circle all the places where the left-hand limit of the function does not equal the right-hand limit of the function. So this is a graph of one function. I've broken it up into pieces. They're kind of color-coded. But what I'd like you to do is figure out when a left-hand limit does not equal the right-hand limit. Take a second, circle the three places where that happens. Now you should have circled that jump here, this jump here, and that jump there. And now what I'd like us to do is calculate the limits in these different cases. So if you take the limit as x approaches -1 from the left of f of x, you should get -1. And that's because as x is moving this way along the x-axis, the y values are staying constant at the value -1. Okay, so the y values is what the limit's reporting, and it's reporting -1. So staying constant at -1 actually. Now, if you look at this as x approaches -1 from the right, then the y values are changing. They're actually decreasing as x gets closer and closer and closer to -1. The y values are getting closer and closer and closer to -2. Okay? So you can see that the left-hand limit in this case does not equal the right-hand limit. We're getting what we call a jump discontinuity in this case. Okay, now the next example to look at is over here, and that is at x equals 2 pi, I believe. So I'm pretty sure that when I plotted this, I put 2 pi there. So let's just say that that's what it is. So we're looking at the limit as x approaches 2 pi, and from the left of f of x, well, the x values as the y values as x approaches 2 pi from the left are moving closer and closer and closer to y equals 0. So we're going to say y equals 0 there is the left-hand limit. And if I want to take the right-hand limit, that would be looking at the y values over here just to the right of 2 pi. So let me just say again that this is the point x equals 2 pi. So the limit as x approaches 2 pi from the right of f of x is going to be 1. That's because the y values are staying constant at y equals 1 over here. Okay. And now the last jump discontinuity happens when x equals 7. So let me write that the limit as x approaches 7 from the left of f of x, well, that's going to be 1 again because this function is just staying constant on that interval. And the limit as x approaches 7 from the right of f of x, so that is going to be 2 because the y values are remaining constant and moving, and they're staying constant at 2 as x approaches 7 from the right. Okay, so hopefully you guys get the idea of how to report left and right hand limits now. Thanks for your time.